All right.
And we're back.
So what we are going to do now is we are going to practice doing some nuclear decay practice, nuclear decay reactions. So everyone look at this sheet right here. It's your nuclear decay practice. It has several problems and it has answers to the problems on the back. So this is notes. We're going to use this as notes. Your assignment for today looks like this. You got 3 different sets of problems and they're all decay reactions. Well, actually the last ones aren't decay, they're combination. But we'll get into that. So let's start with the first one. It says uranium-235 undergoes alpha decay. So if y'all remember from Monday, we write uranium-235 like this. And then we have to look on our periodic table to find the atomic number of uranium. And it's 92. So we put a 92 here. Because what is this? Y'all remember what this number tells us? This is the number of nucleons. It's the total number of protons and neutrons.
Put together.
It's basically your mass. Protons and neutrons. What about the bottom number?
Just your proton.
This is just the protons. It's also called the atomic number. Exactly. So uranium-235 is going to undergo alpha decay. So we're going to put the arrow that tells us that we've got a process that's happening, and we're going to undergo alpha decay. That's the alpha symbol. Does anyone remember what particle this uranium is going to spit out if it's doing alpha decay? No?
What you mean?
I'll give you a hint. An alpha particle has a mass of 4, and it has 2 protons, so it has an atomic number of 2. It's not lithium.
It's
Lithium's
helium.
3. It's helium, exactly. So an alpha particle, don't forget this, an alpha particle equals a helium atom, which is 4, 2, alpha. That's the mass, that's the protons. So we are about to spit out something with a mass of 4 or 2 protons, and it's basically a helium atom. If you want to put He for helium, I'll take it. If you want to put the alpha symbol, I'll take that. One or the other. Okay? So if we spit out 4 nucleons, how many should we have left?
2. 0.
431, right?
Well, we started with 235 of them.
Take away.
And we just lost 4.
331, I'm sorry.
You mean 231? There you go. So we got 231 right here on the mass. What about our atomic number?
90.
90. How'd you figure that out, Kendrick?
2 minus 90. 92 minus 90.
Right. Remember, try to think of this arrow as an equal sign. So 92 equals 2 plus x. So that's going to be 90. Now the question is, how do we know what to write for our element? Y'all remember? So this is the atomic number. It tells us how many protons. So we need to take that number and go to this chart and we look for number 90. Right there. Number 90 is thorium. This is the exact same reaction we did Monday. Y'all should have seen this one. So we've got uranium-235. If it were uranium-236, that would be an isotope, because isotopes are elements with different masses. And ions are what? What are ions, Kendrick?
Ions?
Uh-huh.
Yeah, I just wrote that. I literally just wrote that.
I just told you. We went to the fire, what do you call it, drill. You might have forgotten. Ions are charged particles. Isotopes are atoms of a specific element that have a different mass. Normally, uranium is 238, but we have 235 uranium. That means this uranium is an isotope. All right, everybody have this?
Yes.
Yeah? You have a question?
Do you know what page the atomic,
Periodic table?
yeah.
336. Okay, let's move on to our next one. Our next one says carbon-14 undergoes beta decay. So we've got 14 carbon. What's the atomic number for carbon?
Carbon.
So over here on the right side in the non-metals,
6.
it's 6. So it's going to undergo process beta to decay. Beta decay. Does anyone remember what a beta particle is?
Negative.
It is negative. Does it have mass? No mass. So what subatomic particle would a beta particle be if it has a negative charge and no mass? It's not a proton. Protons are positive.
Electrons.
Electron, exactly. So that is 0, -1. It's also an electron. So this carbon is about to spit out an electron. So let's go ahead and put that. We're going to put our 0 mass, our -1 charge. We're going to write our beta. And then it's going to leave us with what mass? We started with 14. We lost 0 mass, so how much do we have? We still have 14. What about if we had 6 and we gained a negative?
7.
It's going to be 7. So what do we end up with our element? It's going to be number 7.
Neutron.
It's not neutron.
Nitrogen.
Nitrogen. So y'all saw this. This is the decay of carbon 14 into nitrogen that we talked about. We did this reaction together Monday as well. So this should all be a bit of review. So let's try one we haven't done yet. Let's start with, we'll do one of each of your homework problems. That way you can at least get one from each section done before you start tonight. So let's do the first one. We start off with, it looks like 210 polonium. So we got 210 PO for polonium, and it's what, 84. Now what do your instructions say is going to happen to this polonium? What kind of decay is going on?
Alpha.
Alpha. So we're dealing with alpha. So what am I going to put right here?
Negative.
What type of atom is it?
It's a.
It's an alpha particle.
Helium.
Helium. So what's the mass? 4. Yeah. What about the charge?
2.
2. So you could either put alpha or you could put He for helium, whichever one you like. And we're going to be left with what? We started with 210 on our mass. What's our new mass going to be?
206.
206. Exactly. You guys are doing good. 84. We lost 2, so we get
82.
82. What element does that give us? Really?
Lead.
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 Lead. Yeah. It is PB. That's because we used to call lead plumbus. That's where the word plumbers come from.
Is that 82 at the bottom?
Yeah, that's the worst 82 you've ever seen. Luckily, I teach science, not handwriting. There we go. Is that better, Hala? So this is alpha decay. And now we're going to move on to the beta decay. We just did one of those a second ago. You guys got this? Chirp, chirp, crickets? You good? Can I erase? All right. I need to lock the wheels on this thing. I need to keep this. I like this thing. All right, next up, we're moving down to the next section right here in the middle. We did this one. Now we're about to do the carbon 14 again. You know what? We already did carbon 14. Let's do the strontium below it. Okay. We've got number 90 mass. It's number 38, I believe. Yep, strontium, Sr. We are going to undergo what kind of decay? What's the middle section? What kind of decay are we working with? Just said it earlier. Beta. So we're going to do beta decay. So what are we going to lose? What kind of particle are we going to kick out of here?
Beta.
An electron. So the mass is 0. Charge is
-1.
-1. And you can either put beta or you can put electron. I'll take either. And what are we going to be left with? What's our new mass? 90, because we didn't lose any mass. What about our charge? 39, exactly. How do we check that? Well, let's look. Does 39 plus negative 1 equal 38? Yeah, because plus negative is basically subtraction, right? So our strontium lost an electron through beta emission and turned into number 39, which is what? Yttrium. Just a big Y. So if we look on the back, oh, this one doesn't have answers. So you're getting free answers. Remember, your practice has answers, so you can use that.
So we got to turn both of these in?
No, I want you to keep this one right here for your notes because there are already answers on the back. I want you to use this one as your assignment. This is just to help you.
That's what
Alright?
the homework grade?
Yeah, this is the homework, and these are your notes to help you out.
But I'm saying
Okay?
we got to turn it in.
No, I want you to keep this with you. These are notes. So now we're on the last section here at the bottom. Now this one isn't actually decay. It says we're doing electron capture. So what does capture mean? What does it mean when you capture something?
Like put them together. Like
Well, I would say fusing is putting together.
fusion.
Y'all ever play capture the flag?
No.
Oh yeah, on Call of Duty.
For Call of Duty, right?
I don't know
So you
about
go
that.
to capture is to take something and keep it with you, right? So if that's a pin, I can come up and capture this pin. Like, that's my pin. So I captured it. So what's going to happen is these elements are about to capture an electron. So instead of being beta decay, this is kind of a beta synthesis. We're going to add an electron to our element. So let's see what that looks like. What we got? Hey Elijah, do me a favor, walk around, okay, bud? We're filming. So we're starting off with one of my favorite elements, silver. We got 106, and that is Ag,
47.
and we've got 47. Now you'll notice that our plus is on the left side of the arrow this time. So we're going to combine these two together to make our product. So what are we combining if we're going to capture an electron? What kind of particle is it? Alpha, beta, or gamma?
Gamma, right?
Well, which one is a beta particle? A proton, neutron, or electron? An electron. It's right up here, yeah. Beta particle. So how much mass am I going to gain?
2.
No? Zero. Beta particles have no mass. What about the charge? Negative one.
B.
So we have picked up a beta particle and we are going to produce what? What's our new mass going to be?
106.
106. What's our new charge?
48.
48. And what is our new element?
Cadmium.
Cadmium. Cadmium. It's a really cool metal. I like cadmium. C and D. So we have actually gained this electron. Let me highlight that. Before, we were putting our arrow where our plus sign is. But now, here is our arrow. So we're instead of breaking off an electron, it's actually going to combine with our new element. Y'all want to do one more?
Mm-hmm.
I'm already
Yeah.
done.
And see, if y'all heard this, y'all were like, oh my god, this is complicated. This is crazy. It's not that bad, is it? It's really not too bad.
Mm-hmm.
All right, let's do uranium. Let's do thorium. We already did uranium a couple times. We're back at the top section. This is the third one down. It says 238 thorium, and it's going to undergo alpha decay. As a matter of fact, you know what we're going to do? I'm going to see if one of y'all can do it. So
I
we're
know
going to
how to do
stop filming, and just make sure you check this video. If you need any more practice, come see me.